Hello everyone, welcome back for the second video tutorial. For this video tutorial, we are going to talk about universal modeling language and ability to support object-oriented ways of supporting software development tasks. Okay, the whole idea about making software development is ability to reuse existing component, existing class, and then extend existing capability to cover additional requirements. Okay, so that is the best thing for object-oriented programming. Now, before we go into the diagram like this, okay, let me go ahead and create the new project file here. So we're gonna call new solutions, and I'm going to call it as okay midterm. Well, how about this UML1, and I'm going to put it in the same location as the previous project, so let's put it inside desktop locations, which is available right here. Okay, so now I'm creating the new projects. Okay, now for these projects, I'm going to go ahead and implement the class that represent this business entity. Now if you look at this, okay, um, for designer, if they would like to communicate their design perspective with their business partner, it is not possible for them to actually challenge code to non-technical people. For business people, they look at this as like pictures. So to visualize this better, they use what we call UML diagram or universal modeling language, where each box like this, the rectangular box represents each data class. Now for each data class or application class, the first part of the box is the part that we put the name of the class in there, okay, labeled by the name of the class. Now the second part of this box entails information of that class. So for example, in this case, you can see that for custom class it have four different informations, and unlike the codings, you put the data type in front of the name of the informations, but for UML diagram we put colon. We separate the colon by we separate this information name and data type by colon. Okay, and also in this case, that minus represent accessing ability. So if you put private, that means it's private to that class only. If you put plus, that means it is accessible by any other class. Now, in order to show you and visualize this better, why don't we just go ahead and create this class together real quick. So right click, add, new items, class, and we name the class as customer.cs. Then we implement whatever they ask us to do so. So information declaration including private in customer ID. Now you can see that now with minus is tell that this information is privately accessible within the class. Okay, so that's the story. So you can see that all of them are minus, so that means everything will be private in this case. So we're gonna have string of customer name, private of string, and address, and private of integer for phone number. So in this case only, okay. So go ahead, if you want to see the diagram, what you need to do is you have to place F number 8 on your keyboard, and after placing, okay, I think I'm gonna have to do it like this. So I have to build solution. Okay, the reason for that is because I am controlling this remote desktop from another machine. So I'm running on the Macintosh, remoting for Windows machines. Okay, all right. So in this case, we have already created a new data class called customer that contains for information, just like the diagram say. Okay. Now, if you want to see the diagram, what it look like, you can go to the project and then select show class diagram. And it's going to show that right now in your project files, folders, you have two classes. The first class is automatically generated by the system, is the program class that holds the endpoint for the program. The second class is for the customer. Now, if you look at the diagram here, okay, it's just two rectangles. And for each rectangle, the first part entails the class name. Okay, and inside the diagram in the field, this is not the standard for UML. This is only for exclusive for Sharp develops. Okay, but for UML, they're gonna put this like this. Okay, but you can see that it's the same. And this guy also sorted the information name, okay, by alphabet number as well. That's the good thing. All right. And also in this case, since in the customer, we also have these constructor functions. So that's why it lists the constructor function for us as well. Now, if you remove this constructor function here and save it one more time. Okay, sorry, I have to take this off as well. All right, so if you go to class diagram again, you can see that now if you click on it, the methods disappear. Okay, so no more constructor. Now this is not finished yet. So we still have to implement three functions. How do we know this? Because in the UML, another part of the box is the last part. This is used to, list all the functions that will be implemented for the class. So go ahead and do this for them. So now we're gonna implement add customer, and as you can see, it does not return any type because it doesn't have colon on the right hand side. So we put void, and on top of this, the plus, not minus. So when it's become plus, accessibility will be public. Now, this is explanation about the function itself. So what I'm going to do is I'm not gonna put any code in here. Just it's going to be empty functions. So each one of this. Okay. So go ahead and implement more function, which is void edit customer like this. We need one more function here, which is public void delete customer. All right. So if you want to see changes, if you go to projects and say show class diagram, you will see that it's not going to be there until you say reloaded it. Okay, so now you got the customer with update information of the method section. The method section is a function section basically here, and it shows us about, okay, how many functions we have. But in Sharp Develop, it doesn't show you the accessibility level here. Okay, so in the exam session here, I just want you to follow this. All right. Okay, what is next? So this is one class. Now, you can see that what if I quit the job, for example, I created the class customer, and my boss say that, okay, that my boss say to the new guys that responsible for my task, I quit the job, he came in and then he take over my business. So boss say that, okay, good, but he just want to implement one more information. Okay, so if you are the new guy, you say, oh, it's easy, so go ahead and just implement another okay, how about this? Another information. Let's say public. Let's put email, for example. That's what's gonna happen here. Imagine that this class has been done and many program is utilizing this customer. So in this case, for example, there might be team number one who developed this, and then they're more than happy to use existing class called equal to new customer like this. Now, the problem with this implement and team 2 as well, team 2 also have customer as well. Now imagine that this program are separate two program, okay, handled by two separate teams. And team number one use customer objects as well based on this. Now the problem is that Now the new guys have just implemented additional information in here. Now the team one say, no, I don't want to see any changes, because otherwise people will be able to call email, and we don't want that because we don't want emails in our implementation. But the new guy does this in favor to team 2, because team 2 requests this and say, hey, I want email information as well. Now you can see that there are conflict right now, that one team doesn't want the new things and the second team want the new implementations. Okay, in this case email. So how to resolve this problem allow this is to actually create the new class. So the new guy say, okay, go ahead, I can just call the customer as the special customer now. So customer with email. So he go ahead and just using the old guy class and remove this, and he can without knowing OOP, he go ahead and create another class called customer with email CS. And what he did with this would be just go ahead and copy this real quick. Okay, copy this and then put it into the new class directly. So now that's the implementation. And what he need to do is just say, hey, I add the new one as public information email. And then he informed the second team saying that, hey, from now on, you should not use customer, but you have to use the class name customer with email. Customer with email. Like this. Which is totally fine. Totally fine. I mean, both teams are happy. The first team must still stick with the original class without changing anything. And the second team work with the new class that have added this information. Fine, good, job done. But the problem is, what if I have to change this from time to time, many times, and there are hundreds, thousands of this information implemented. And on top of that, this class might not be available as the source file. It might be compiled into special file that have extension .dll already, so you cannot see the code. Okay, so in this case, you cannot just simply, create the new class and add the new informations. This is going to be, time-consuming task. So OP say, how about this? You can still create the new class, but you don't need to worry about anything at all for this, because we're gonna take care of that. So they say here we go. When you create the new class, but you want to base that the new class based it on the old one, and you want to take anything that the old one has, okay, and then add the new thing in. So in this case, you just have to say this. You say, hey, new class, why don't you derive, okay, existing information, existing implementation from this class. How do we say this? We say we want you to derive it from customer, okay, derive from customer. And now this operator, okay, that dot colon represent association relationship. Okay, how about this relationship? Okay, that new the customer with email, okay, extend, inherit, or derive from customer. So when it extend, inherit, or derive from this class, okay, whatever the class have in terms of this asset, the new class will automatically understand it. So no need to implement this old one that is already there already. No need to implement this because it's already there. Now, by saying that this class is extend from this class, everything that this class have, the new class got it. Okay, to prove my statement here, I'm going to remove this first. So technically, this class is inheriting everything that the customer has. Okay, so let's go back to our business here. I'm going to make the comment for this. Now let's say F number 8 here. Let me build it first. All right. Now you can see that you can have access to add customer, delete customer, and edit customer. What in the world why this is possible? It's because, for example, in this case, when you have it like this, okay, the computer will say, hey, who you are, C. C will say, hey, I am the object belong to this class. And the computer will say, okay, I know that you belong to this class. What do you want to do? They say, I want to call this function. So the computer will say, okay, good. So I want to check to see if this function is implemented in this class. So they go ahead and look at this. And as you can see, there is no such implementation in this class. But the computer say, hey, hold on. But this class is inherited from this class. So what I want to do is, I want to go check this class for you. So they go check this class and review that, oh, it's actually in this implemented right here. So that the computer will call the function from here. So the good thing about reusability is, as you can see, you inherited your class from other people work, then when whatever they have in terms of public, you can have access to it. Now you can see that you cannot have access to the private at all. Now look at this. If you're trying to say C dot, as you can see, there is no such customer ID, customer name, address, and phone because they are labeled as private. Now let me turn one of these on. Let's say the first one, let me turn it on as public. Then I save it. All right, now if I go back to this and see if this is possible, as you can see now I can have access to the customer ID. Now you know what happens behind the scenes. The computer will say, see you who you are, and see you say, okay, I am the object belong to this class. What do you want to do? I want to access to this information. So the computer will say, okay, good. So I'm gonna go look it up from this. So they're gonna go look it up, and it doesn't have any declaration for customer ID. But computer say, hold on. I know that you guys is inherited or extend from this. So I'm gonna go check it out from customer. So they go check it out from customer and review that, oh, in this is the public, so that it's allow you to access for this. So that the whole concept of reusability, you can reuse whatever have been developed, okay, in the previous one. And this guy is just to say inherited or extended from here, and the object for this class can access to any public property for the previous class. Okay, one more things. Now for the second class, now you can say, hey, because the boss say I need to implement additional email, so go ahead and implement email. So in this case, so it's gonna be public string email. Save it. All right, now if we go back to program, because this is the new class that extends from the customer, so now it would be able to access the customer ID. Okay, the customer ID is labeled as public from the class of customer. Now also, it also have ability to access additional email. See? So now that means from now on, we have two classes. One that the team number one will be used without any changes. Now this class will be used by second team, that second team still want to access to customer ID, okay, and also be able to access to the new information that is implemented in here. Okay, now in OOP terminology, if you have the relationship like this, okay, in terms of the diagram, it's gonna let's take a look at this. So I'm gonna show you that if you click over here, now we have association relationship. As you can see, there are one more box that is labeled as customer with email over here. And since this class is extended from customer. In the diagram, there we have an arrow, okay, that is starting from the one that extends from here. Okay, the arrow go to this direction. Now, in order to represent this relationship in UML world, we have technical term for this. Okay, the one who provide the extension, we call it as parent, and the one who inherited or derived from this is called student or child. Okay, so if you look at this relationship, we know that this one is extended from this. So this class is acts as the parents that provide public asset like this. And also this class taking, inheritance from this. So we consider that this is the child of this class. Okay. Now, if you look at this and answer question, you have to understand that now for the parent class, is have implement for information, but only one public that the child class can use. Okay, so in the child class, it also have its own implementation of email. Okay, so when I ask for this, hey, for customer with email, how many information that it can use can access to, can have access to. One of them is, of course, the one that implement directly in here. The other one is you have to resource to the parents and say, oh, another one that are public. Anything private is impossible. Okay? All right, because sometimes, the designer doesn't want the team to access to the private information. So in this case, you can see that only customer ID is available as public. So that's the technical things that we are going to cover this after midterm exam as well. But for this, just to give you some understanding about this. Okay. Now, when you have parents, you have child. You can also have students. For example, another team comes in and say, "Hey, I want everything that you have here, but I also want to implement one more. I don't want to extend that from here because you don't have email. This class already have email. I want email, but I want something more like maybe um, line number, for example. So instead of extended from this, okay, it doesn't have email, so forget about it. It extend from here, yeah, possible. So go ahead and implement add new item and call customer with line number cs, and in here you just implement string of line number, for example, and we say that this class will extend from, okay, customer with email. Okay, then you save for this, while you save it, then you build for this, and okay, oh sorry, let me remove this first, save it, and then rebuild this one more time. Okay, now in terms of relationship, let's examine the diagram together. Go to projects, show class diagram. Now there would be one more box in here. So previously we know that we have parents as customer here. We also have child class, which is called customer with email. Now we have another class which is called customer with line number. Okay, all right, good. So there are two relationships now, okay, expressed by the arrow line. This is to say that this is the child of this class. Okay, so this class is the child of this. This is the parent of this class. Same thing. This customer with email is the parent for this class. Customer with line number is the child of this class. So you might wonder, okay, direct relationship, this is okay, understandable. But what about relationship between this one and this one? So we are going to call this class as the grandparents of this grandchild. Okay, so to this, to this. This is the grandparents, and to him or to her, this class is the grandchildren. All right. Now, the good thing about this is now another team number 3, so they can create another object here, and they say they don't want to mix up with team 1. They don't want to also mix up with team 2. They just want to, have their own freedoms. That when they created this new customer with line number, then they should be able to access to newly input for, okay, let me look at this with line number here. So I already have line number, customer with line number. Let me save it first, rebuild this. Now if we go to the program with line number, as you can see that's the same name, right? So this should be C1, C2. Now for C2, you can have access to both line number and email. Okay, so if you access to line number is easy because they say, hey, C2, who you are? Okay, the computer will review that C2 is belong to this class. So they say, okay, I know that you are object for this class. What do you want to do? And we say we want to access to line number. They say, okay, good. I go check it out for you. So customer with line number here. Oh, you indeed have implemented it. So you can have access to this. Now, they also can call C2.email. Now, same thing. So C2, the computer will say, okay, I know you are from this class, so I'm going to go to see if you have email implemented inside this class. So they go check it out for you and they say, no, there is no email. But hold on, you inherited or extend from this. So let me go check for this. So they go check and they say, okay, you implemented this in your parent, so you are qualified to call this or access to this. Okay. Now what else? Also, C2 can have access to customer ID. What happened? So C2 computer will say, hey C2, you want to access to this? Let me go check it out. Your class doesn't implement customer ID. But hold on, you extend from this. So the computer will go to this and say, okay, there's no such customer ID. But hey, hold on, you extended from here. So let's go check this class, and finally they say, oh, this information is labeled as public asset. So you should be able to access to it. See? So this is what we call reusability. Okay, so in the diagram, you can see that we have the arrow line representing this. Okay. Now, as you can see that if I give you the diagram that look like this, okay, doesn't mean that I want you to do something with the entity diagram, but I want you to create classes, like 3, 4 different classes, okay? Have the name of the class, informations, some are minus, some are plus, okay? And then the instruction might say, for example, create full classes that support UML diagram. I think this is easy done. I have shown you how to do this already, okay? So you create 4 different files for class, customer, order, products, and stock. And then what else? They say create a new interface class that refactor to different functions, signature from stock. I'm going to jump from this to this first. They say create a new class that this class is inherited from stock class. Inherit is just using colon. So in this case, so you are supposed to create okay. The special stock here that extend from stock, okay, and then add overloading function modify stock. So you just have to add the implementation for modify stock and select stock item. That's it. Okay, no need to do something else. And we are going to talk about this overloading function after midterm exam. For now, when they say add one thing more, you just have to implement it. Okay, all right. Now, speaking of interface, okay, speaking of interface. So for example, in the previous example, we have the class called customer that implement 3 different functions. Imagine that you are a business analyst. You go talk to customer directly. The customer say, hey, we want you to implement 3 functions, which is okay. Okay, so the developer did this accordingly based on the requirement. There are 3 of them, you satisfy all of them. Good. But what if the the developer just, did not implement this, but they tell you, he tell you, she tell you, whatever. Okay, they tell you that they have implemented 3 functions already, but they just did 2. How do you know this as business analyst? Okay, so you say, okay, in order to make control over the developer, why don't we just create a new interface requirement that the class have to conform, otherwise it's going to show error messages. Okay, this is the deal. So go ahead and right click, new item. Now instead of class, we are going to put interface, and then I'm going to call requirement from customer A, for example. So that's gonna be my interface. And in here we include only function or method signature or structure, including function name, input parameters, and return type, without having to add actual logic. For example, now from customer point of view, what they want is they just want 3 different functions like this. Okay, so as the business analyst, you can develop the requirement by yourself here, and then you put the let's call this end of interface. This is the end of interface class. This is end of namespace. And you say that what you need to do is you just put signature. Now let's take a look at the first functions that they need. The name of the function will be add customer, doesn't return type, doesn't take input. So what you need from here is you say method 1. Okay, I know that you have to put add customer, doesn't take input, so you put just empty parentheses. Doesn't return type, you put void in front of this. And then just unlike actual implementation when you have to put bracket here, no need. You just put the name, specification of input parameters, and semicolon, like this. Same thing, go for this one, edit customer. So go ahead and add edit customer and void. Alright, now we have already created what we call interface requirement. Okay, this is the name, could be any name. You say this is from customer A, so you put the name like this. And you want developer to conform to this structure. Okay, so you say, hey developer, in your class, make sure that you implement this requirement. Also, the requirements say you need to have 2 implementation for the first one, add customer, the second one, edit customer. So developers say, okay, from now on, I cannot cheat you, so I have to go ahead and put over here, implement, we use the colon as well, just like extend or inherit, implement from requirements customer A. And if I build it one more time here, oh, this is supposed to be comments. Then go to build here. All right. They say that customer does not implement interface number. Okay, edit customer. So you can see that customer 1, look at this one more time. The customer want this to be lowercase and lowercase, both of them, see? But in the actual implementation, the name is not correct. See? So that means now, from now on, when you you say you conform, you implement these requirements. You have to actually implement this to function exact name. Now, as you can see, the name is a little bit different because this needs to be lowercase. Now, if I build it one more time, now you can see that it's gonna say, hey, no, you still have to implement one more, which is edit customer. Now you don't have edit with lowercase, you have to conform to me, so it is customer. And developer cannot finish his job or her job by, fixing this. And now if you build it, rebuild it, okay, the all right, so let me comment this. All right, so this is okay. Now, imagine in the future, uh, the business analyst go talk to the customer, and the customer say, "Okay, I want you to add more function for me." So, what the business analyst have to do is just to say, "Okay, the customer want to delete customer as well, and take input like integer, and return integer, for example." Okay. So in this case, you can see that the name of the function is delete customer. Take one input parameter. The type is integer. It's also return one type as well. So you did this inside. Business analyst did this inside requirement interface file. Now let's see what happened. If developer trying to build this, it's gonna say no, because in your development file you still did not implement additional requirement, which is delete customer. So developers say, okay, now I know that I have to add this. So they go ahead and put public void delete customer like this. Okay, and then build it again. And the computer will say, no, the reason for this is because if you look at the requirements, if you go to requirements say that you cannot take 0 input parameter, you have to take one belong to integer. So developer come back, fix it, put in I in there, rebuild it. As you can see, still complaining because as you can see that in the requirements, they say so that this function return numbers as integer. So in this case, this function that is just added doesn't have any return thing. So you have to actually return something as integer. Let's return something like 1. Now if you rebuild it again, then it works. So as you can see, that interface will help us accomplish things that we call software control. I mean, it can be used for other stuff as well, but for now, one of the benefits of having interface is we can separate the roles of developers and business analysts as two. So business analysts go develop interface by themselves. Okay, they just don't need to put logic at all. What they do is they just put signature of the function, including the name, specification of input, specification of output, and we put semicolon at the end of each signature. Now, once the interface is done, the developer, if you want to conform to business analyst, then you have to just say, hey, I can implement an interface from this requirement. And it's allow us to see whenever there is any new implementation pop up like this, then developer would know that, okay, I need to implement this more, but in this function, it doesn't actually have any logic, and developer had to implement the real logic in there. So it is the good idea to, let's put logic for delete customer, take input, and then and return input multiply by 3. So that is the human description that business analyst would ask from the customer. Okay, now whenever there is an error that is not there yet, okay, or even if the customer say no more delete, I want remove, for example, Now, if the developer rebuild the solution themselves, they would discover that, okay, they want remove customer, and we have this customer, and they will say, hey, what's going on? So they can go to the definitions and discovered, oh, it's have changed the name already from delete to remove, and it's also show now that this is the logic. So developer will say, okay, so I can finish my job by return this number multiplied by 3. See, so that is the communication between two roles. One is business analyst, the other is developers. Okay, so speaking of interface, now you should know that interface file is just like requirement file that contain, signature of functions. Whenever any class that implement that requirement actually have to implement it, otherwise gonna yell, system gonna say no, you have to implement it. Now speaking of exam, you can see that now if I say create a new interface, so you create a new interface class that look like mine, and they say refactor different function signature from stock class into interface class. Okay, so if you can see that okay, how about we create the stock class together so you know what I mean. So let's go ahead and create a stock class real quick. Add new item class stock .cs. Inside this stock class here, let's go ahead and implement. I'm gonna leave this implementation for information declaration for you, but I'm going to implement public add stock. Okay, and then we have public. Whoa, it doesn't return type, so void public void modify stock take integer product ID, doesn't return anything. Also public void select stock item take integer as well. All right, so that's the stock. Okay, now they say to create a new interface class named interface stock, and then refactor 3 different function signature into interface here. So what it means is, in this case, okay, to make sure that this class in this implement this, so you go ahead and implement add the new interface class, and the name of this class is called interface stock.cs. Okay, inside this class you have to add 3 different signature like this, so just like the previous one. So we put public void add stock, and without bracket, okay, without bracket, it's just the signature, so you put semicolon directly at the end. Same thing here, public void modify stock, and in product ID public void select stock item in product ID. Okay, now when I say refactor means we already have this implemented as the requirement from customer under these requirement names. Okay, then you say, hey stock, could you please implement this interface? This is what I mean. So you can just normally go to create the new interface class, then whatever you have in here, you put those signature without logic, just like this. Okay, and then you fulfill this requirement already. All right, we are going to talk more about this, relationship UMLs and benefit of this later after the midterm exam. So feel free to talk about this. I will upload it to project file here to GitHub, and also video tutorial to the Facebook. And if you have any question about this, we can review all of this again on Saturdays at 6 p.m. to 8 p.m. I'll see you there. Thank you for watching.